Okay, so we are starting on page 39 for today. We talked about vertex form last time in this sort of format that we can have just for quadratic functions, right? Our broader category of polynomials, not everything gets a vertex form, specifically for quadratics. And we talked about if I have vertex form, what does the vertex look like? How do I get it out of that function form? Or if I know the vertex, how do I write vertex form to be able to represent that function? What we're going to talk about today is how to swap from vertex form to standard and to factored. We did this already with factored and standard earlier in our unit for any type of polynomial. If I've got factored, how do we get standard? If I've got standard, how do we get factored? We spent a bunch of time on that. Today we're going to look at, starting with vertex form, how do I get those other two formats for a quadratic function, okay? So just as a refresher, let's talk about the thing that we've already done. So if I've got factored form, how do I change it to standard form? What's that process called? Yeah, distributing. How do I change it to standard form? I distribute.
How do you distribute?
Yeah, the thing with the thing, yeah, that's just distributing, okay? So, FOIL, yeah. So if I've got factored form, we will distribute x times x is x squared, and then plus 1x minus 7x minus 7, you know, the thing. And then don't forget to combine your like terms, okay? So we've got two terms that are just x's in here. We need to combine those for standard form. So we would have x squared minus 6x minus 7. There would be the standard form of that function. What does standard form tell us? Tells us something about the graph. The y-intercept. What would be the y-intercept for this guy? Very good, -7. That's why we care about standard form, right? Because we can get some information from this. We also get some particular information from factored form, and we'll talk about that in just a minute. If I have standard form, how do I get factored form? I have to factor, right? It's right there in the name. I have to factor. So we've got a function here in standard form. I would start by looking for a GCF, which we don't have here. Since my lead coefficient is just 1, I'm going to use guess and check. So I'm going to look for factors of -8 that add to -2. That would be 2 times -4. So my factored form would be x plus 2 times x minus 4. And there's factored form for my function. What does factored form tell us? The x-intercepts, what are the x-intercepts for this function? -2 and +4. So the reason that we care about being able to swap between all these different forms is because I can get different information from the different function formats that we have. Now, way back in Algebra 1, we did this with standard form, factored form, and vertex form. So the stuff that we're going to do today should be familiar because we did do this last year in Algebra 1. Okay, so for today, we're going to look at, if I start with vertex form, how do I get to those other function formats? How do I get to standard form? And then there are some cases where I can also pretty easily get to factored form. So that's what we're going to look at for today. So towards the bottom of page 39, really towards the middle of page 39, we're going to start with changing from vertex form to standard form, okay? So I'm going to handle this the same way that we handled changing from factored to standard, okay? We're going to distribute. The only sort of extra piece that I get here is that part that's written as a square, I've got to write it twice before I can do my distributing. So that's going to be our first step here. Take the squared piece and write it twice. That's what square means. It means this thing times itself. In order to be able to distribute, I need to write it out. So I write that squared part twice and then redistribute. So x times x is x squared minus 1x minus 1x plus 1. And then don't forget our plus 3 at the end here so that we can combine our like terms. So we would have x squared minus 2x plus 4. There's my standard form. For our next example, exact same idea. The difference is this time my lead coefficient is not 1. So I'm going to have another thing that I need to multiply. I'm going to start the same way. I'm going to write the squared thing twice. So this would be 3 times x plus 2 times x plus 2 with that minus 5 there at the end. Remember, when we're multiplying, we only multiply 2 things at a time. I don't care which 2 things you start with, but only 2 at a time. Okay? So I'm going to start with the 3 and the x plus 2. So that would give me 3x plus 6, then multiply by x plus 2. So that would be 3x squared plus 6x plus 6x plus 12. Now as we're going to combine like terms, don't forget that minus 5 at the end. And my standard form would be 3x squared. 6x plus 6x would be 12x, so plus 12x. And then 12 minus 5 would be 7, so plus 7. Standard form. So if I want standard form, I distribute. When we're looking at changing from vertex form into factored form, okay, there are some problems where I can actually go directly from vertex form into factored. Sometimes we're going to need to take it through standard form first, but there'll be times, a lot of times that I will show you, anytime that I'm asking you to do this, generally you'll be able to go directly from one to the other. And the idea here is that we're going to use that difference of squares pattern. So if you remember, difference of squares looks something like this. I had 2 terms, even degree, subtraction. This thing's a perfect square, so is this thing. So we said, hey, figure out what you squared to get each of those terms. So this guy would be 2x, this guy would be 3. And then our factored form looked like the first thing plus the second thing, and then the first thing minus the second thing. And that's my factored form using that difference of squares pattern. We can use this same pattern to go from vertex form into factored form. These vertex form problems are really kind of set up like a difference of squares, right? I've got something squared here. It's already written like that. It's already written as something squared. Minus 16 would be 4 squared. So I'm going to use this same pattern from our difference of squares factoring to be able to change this into factored form. So this would be the first thing, which is x minus 3, plus the second thing, which is 4. And then the first thing again, x minus 3, minus the second thing. The only extra step I have here is to combine like terms and tidy up my factors. So this would be x plus 1 and x minus 7 for my factored form. So we're taking advantage of that difference of squares pattern to help us swap forms here. Now for our last example on page 39, I have a lead coefficient that's not 1 for my vertex form. In order to be able to use my difference of squares pattern here, I'm going to take this out as a GCF. So right now I've got 2 times this thing minus 8. So what I'm going to do is factor 2 out of here. So that would just leave me with x minus 1 squared. And then for my second term, negative 8 divided by 2 would be negative 4. Now, this is already written as something squared. And 4 would be 2 squared. So when I use that difference of squares pattern, I get x minus 1 plus 2 and x minus 1 minus 2. Don't forget your GCF in front. And then final step, tidy up your factors. So this would be 2 times x plus 1 times x minus 3. Questions for me so far? Okay, we're gonna do some more of these on the next page. So go ahead and turn the page for me. So on page 40, in the first table, all of these problems are starting in vertex form and we're changing to standard form. And then the bottom half of the page, all of these are starting in vertex form and we're changing to factored form. We're going to start up at the top. Standard form is what we want to get. So that means we're going to do some distributing up here. So for number 1, I've got a lead coefficient here that's not 1. That's okay. I'm just going to write it in front and then write the squared thing twice. The first thing I want you to do anytime you're changing to standard form is to write the squared thing twice. Now we can start multiplying. Once I have everything written out, then you can multiply. Do not distribute something into a thing that has an exponent. So do not distribute the lead coefficient in here. It has an exponent. You need to write it out first. So I'm going to distribute this -2 first. That would be -2x plus 2. And now we multiply by this other x minus 1. Distribute again. So this would be -2x squared plus 2x plus 2x minus 2. Don't forget to bring down your plus 3 from the end. And now we combine like terms. This is my only x squared term, so -2x squared plus 2x would be plus 4x. Minus 2 plus 3 would be plus 1. For number 2, again, I want to change to standard form. So I'm going to take the squared thing and write it twice. X plus 2 times x plus 2. And minus 1 at the end. Now I'm going to distribute. So I get x squared plus 2x plus 2x plus 4. Don't forget your minus 1 at the end. And combine your like terms so you have standard forms. So that would be x squared plus 4x plus 3. Questions for me so far? Okay. Now on number 3, we don't have a number that we're adding or subtracting off the end. So our y coordinate for our vertex would be 0. What I notice is, again, I have a lead coefficient that's not 1, so I'll have to distribute that in. But for this problem, it's a half. I'm going to start the same way I've started every other time by writing the squared thing twice. So this would be a half times x minus 5 times x minus 5. Now, the last problem that was similar to this, back at number 1, I went ahead and just multiplied the first 2 terms and then multiplied by the third term. However, this time, our lead coefficient is a fraction. And if I were to distribute this in, I would get a half x minus 5 over 2. Okay? And that's okay, that's fine. But keep in mind that I wouldn't be done at that point. I then have to multiply by another x minus 5. And maybe I'm not really digging having to multiply things that have a fraction attached to them if I don't have to. So another option is that you multiply these guys together first and save the 1/2 to the end. That's what I'm going to do here. I'd rather not have to mess with fractions until I absolutely have to. So I'm going to distribute these first. So x times x is x squared minus 5x minus 5x plus 25. And then I'm just going to tidy this up a little bit. I've got some like terms in here. That'd be x squared minus 10x plus 25. And now I'm going to distribute through that 1/2. Okay? If you don't mind working with the fractions, then multiply the 1/2 first, and that's absolutely fine. But I know for many of us, if we can save the fractions until we have to deal with them, that would be our preference. So that's what I'm doing here. So 1/2 times x squared would be 1/2 x squared. 1/2 times -10x. Well, half of 10 would be 5. so minus 5x. That's not so bad. And then half times 25. I'm just going to leave that as 25 over 2. If you want to write it as 12.5, that's fine as well. But a reduced fraction is also fine with me. So maybe this isn't the prettiest c value or y-intercept in the whole world, but that's okay. Questions for me on 1, 2, or 3? Okay. Now I want to hop down to number 7. I want to hop down to the second table here. In the second table, we are changing to factored form. So we're going to use that difference of squares pattern here. In number 7, it's already set up pretty nicely for me. Okay, I've got that first term written as something squared minus another perfect square. So I just need to say, what did I square to get 16? Well, 4. Now I can use that difference of squares pattern. First thing plus the second thing. And then first thing minus the second thing. Now I'm going to tidy up my factors. So that means I'm combining the like terms in here. I'm combining those numbers. In my first factor, negative 3 plus 4, that would give me 1. So I have x plus 1. In my second factor, minus 3 minus 4 would be minus 7. So I have x minus 7. There's my factored form. In number 8, I see a lead coefficient here that's not 1. So I want to start by factoring this out as a GCF. So I'm going to pull that 3 out front. I've got x plus 1 squared. And then 27 divided by 3, that'd be 9. So minus 9. Now my first term's already written as something squared. 9 would be 3 squared. So this would be, don't forget your GCF in front, 3 times x plus 1 plus 3 times x plus 1 minus 3. And then don't forget to tidy up your factors. Combine those like terms in there. So our final factored form would be y equals 3 from our GCF. And then x plus 4, x minus 2. Questions for me so far? Okay. And then number 9. I'm in Vertex form. I want to change to factored form. Again, we're going to use that difference of squares pattern. My first guy is already written as something squared. So my second term would be 2 squared. So this would be x plus 3 plus 2 and x plus 3 minus 2. Tidy up your factors by combining your like terms. You get x plus 5 and x plus 1. Questions for me? Okay, so we did 3 examples of each together on page 40. There are 3 left. That is what I would like you to work on now. Which ones? On page 40, the 6 remaining problems, the ones that we didn't do together, I want you to do now.